Hi Year 11, this is our second lesson for the topic Arithmetic and Algebra. In this lesson we're going to cover algebra. So last lesson we learnt about real numbers, rational numbers and irrational numbers, and we covered absolute value and exact value. So we've got quite a bit to get through. We're going to look at expanding binomial products, factorising quadratic trinomials, both the monic type and the non-monic, and then we'll finish off with algebraic fractions. Now, much of this should be revision for you, but when we're expanding brackets, the term in front of the brackets is multiplied by every term inside the brackets. So if we want to multiply 4 by x plus 3, we're going to do 4 times x plus 4 times 3, which is 4x plus 12. If we've got 3 terms in the brackets, then we multiply the front term by every other term. That's going to give us 2x cubed plus 6x squared plus 2x. Now when we have a negative in front, we're going to multiply that negative through the bracket as well. So we're going to get negative 2x plus negative 8. And of course a plus and a minus make a minus. Another way you can think about it is that the minus in front of the brackets changes all the signs in the brackets. Can you see that? See this negative here? This was a positive, but now it's negative. And then finally this one. And this is negative 1 lots of x, take away 5, so it's going to be negative x plus, so that minus and minus make a plus, 5. Now binomial means 2 terms, and if we have a binomial product, it's just a set of 2 binomial expressions multiplied together, like this, x minus 2 in brackets, x plus 5 in brackets, or 3y minus 1 in brackets, y plus 6 in brackets. But the pronumerals don't actually have to be the same. So this is also a binomial product. When we're expanding binomial products, we use FOIL, which stands for first, outer, inner, last. And you have learnt this back in the beginning of year 9. So we're going to do first, outer, inner, last. That's going to give us this, x squared plus 3x plus 2x plus 6, and we can add these 2 terms together. So x squared plus 5x plus 6. Let's try another one. We're going to get 2x squared, take away 10x, take away x, plus 5. And joining these 2 together, we're going to get negative 11x, so there's our answer. Now there are a couple of special cases that we need to be aware of. And the first one is perfect squares. That's where you've got a binomial and we square it. It's exactly the same as this x plus 3 times x plus 3. Now we can do FOIL on this and go first, outer, inner, last, and then join the 2 together. But there is a shortcut. Let's have a look where these terms come from. This one is the first term squared. And this one here is 2 times this product. So 2 times 3 times x. And this one here is the last one squared. So let's see if we can use the shortcut with this question. 3x take away 1 all squared, so I want 3x all squared, that's 9x squared, take away 2 times 3x times 1 is 6x, plus 1. And the other special case is the difference of 2 squares, and it will look like this. It will have the same first terms and the same last terms, but different signs. And when we do FOIL, we end up with this situation where the middle terms cancel out. And we're left with the difference of 2 squares. See, the difference of 2 squares, x squared and 3 squared. Now we can always do FOIL and then cancel, but let's use the shortcut. We only want to do the first and the last. So that's going to be 16x squared, take away 1. Now we can go beyond binomial products when we expand brackets, like these examples. How do you think we do this first one? We want to multiply x plus 1 by x squared plus xy plus 1. All we need to do is multiply the x by every term in this second bracket, and then multiply the 1 by every term in the second bracket. I'll leave you to have a go at that one. What about this one here? Well, this is the same as a plus b times a plus b times a plus b. So work this one out and then you will end up with something similar to this that you can continue with. Now, factorising is the reverse of expanding the brackets. So this is what we've been doing, expanding. If we go the other way, we're factorising. And if we want to factorise fully, we have to make sure we take out the highest common factor. Now, numbers and or pronumerals can be factors. Look at this example, 6x squared y plus 4x. Right, I've got a common factor of 2 and also of x. So I'm going to bring that out the front. Then I say 2x times what gives me 6x squared y? I need a 3, an x, and a y, 3xy. And then 2x times what gives me 4x? Well, I need an extra 2. Negatives can also be factorised out. So if I've got negative 4x take away 8, I'm going to take out the negative 4. Make sure you change the sign in the brackets, because remember, negative 4 times positive something is going to make negative here. Negative 4 times what gives me negative 4x? That's x. And negative 4 times what gives me negative 8? That's positive 2. Now, if we have 4 terms, an easy way to factorise into 2 brackets is just to take a common factor out of each pair of terms. For example, ax plus 2a plus 3x plus 6. We're going to factorise the a out of these two and the 3 out of these two, like this. Now we can see that we have a common factor of x plus 2 in each case, and we can bring that out the front. So it's going to be x plus 2 multiplied by a plus 3. So a quadratic trinomial has 3 terms, and the first term is squared. So it'll be like x squared take away 6x plus 8. And many quadratic trinomials can be factorised into 2 brackets, like this. So instead of x squared take away 6x plus 8, we can write x minus 2 in brackets multiplied by x minus 4 in brackets. Now when we expand x minus 2, x minus 4, we get x squared take 4x take 2x plus 8, which is x squared take away 6x plus 8. Now to be able to factorise back into the 2 brackets, we need to know where each of these terms comes from. So this first one is the product of the first terms, x squared. The middle one is the sum of the outer and inner products, so negative 4x take away 2x. And the last one is the product of the last terms, negative 2 multiplied by negative 4. So let's have a look at how we might factorise x squared plus 5x plus 6. I'm going to start by drawing up 2 sets of brackets. And then I'm going to break this x squared term into x and x, like that. Now the real key to solving these sorts of questions is to look at the last term. If it's positive, the only way we can multiply to get a positive number is if the signs are the same. So we're either going to have 2 pluses or 2 minuses. In this case, we're going to have 2 pluses. And this is what we ask ourselves. What 2 numbers multiply to give positive 6 and then add to give positive 5? And they must be 2 and 3. And we put them in, they can go in either order, and that's our answer. If the sign of the last term is positive and the middle term is negative, then the signs in the brackets will both be negatives. But we're going to ask the same question. What 2 numbers multiply to give positive 6 and add to give negative 5? And in this case, they're negative 2 and negative 3. And so our factorisation is x minus 2, x minus 3. You might be saying, well, how do they add to give negative 5? Well, we go negative 2 plus negative 3. And remember, plus and a minus next to one another makes a minus. So negative 2 take away 3 is negative 5. Now let's look what happens if the signs are different. So we're going to start the same way. But if the sign of the last term is negative, then the signs in both the brackets will be different, because that's the only way we can multiply to get a negative. We're going to ask what 2 numbers multiply to give negative 6 and add to give negative 1. And they are positive 2 and negative 3. But this time it does matter which way around you get these, because if we put a positive 3 and a negative 2, then we're going to end up with positive x in here. So here's a hint. Check the sign of the middle term and make the larger number this sign. So we want the negative in front of the larger number, which is the 3. Here's some examples. Now I suggest that you pause the video and have a go at these questions and then come back and we'll go through the answers. Okay, welcome back. Let's have a look at this first one. X squared plus 9x plus 8. Into two brackets. We have got x and x. We want factors of positive 8 that add to positive 9. They have to be plus 8 plus 1. And remember, you can have these two the other way around if you want. Number 2, this time we've got y. I'm looking at this sign here. I know my signs are going to be different. So I want factors of negative 10 and I want them to add to negative 3. So let's think we've got 10 and 1. Nope. 5 and 2. That will work. I want the bigger one to be negative. So I want negative 5, positive 2. And then finally this one. Again, I've got different signs. X, X. I want factors of negative 24 that add to positive 10. 24 and 1? No. 12 and 2? Yes. I want the bigger one to be positive. So plus 12 minus 2. Remember, you can always expand your brackets to check your answer. Okay, we looked at these special cases before when we were expanding, and the first one is perfect squares. So it'll look something like this. We're just going to do it normally. We want factors of 9 that add to 6. They must be 3 and 3. And as an extra step, we can write it as a square. How about this one? We want factors of 25 that add to negative 10. They must be minus 5 and minus 5. And so the answer is y minus 5 all squared. Now the difference of two squares questions, they look significantly different because it's missing the middle term. So you've got to recognize this. You've got to think, I know this one, it's the difference of two squares. They're quite easy to do though. We just go into brackets, we do the square root here, which is going to give us x and x, and the square root here, which is 3 and 3, and we just want different signs. See if you can do this one. So square root of 4x squared is going to be 2x and 2x, and square root of 25 is 5. So we want 2x plus 5, 2x minus 5. And that brings us to non-monic quadratic trinomials. And that's where the x squared term has a coefficient other than 1. And they're more difficult to factorize. Firstly, we look to see if the coefficients have a common factor like this one. And that's going to make our life a little bit easier. So here you can see this is non-monic because we've got 2x squared, not 1x squared. But 2 goes into every single one of these terms. So I can actually factorize the 2 out like this, and then factorize like we did before. Now when there isn't a common factor, there are 3 main methods that we use. Straight into the brackets, product sum factor method, and the cross method. Now if these numbers here and here are sufficiently small and they don't have many factors, we can actually just go straight into the brackets. I'm going to start the same way with the 2 brackets and look here. Factors of 2x squared are 2x and x, so let's put those in. And factors of 3 are 3 and 1, and I'm just going to use trial and error. So let's put it in as a 3 here and a 1 here. Now I'm going to be multiplying those two together and these two together to try and get negative 5x. And I know from looking at this the signs are going to be different, so I want the bigger one to be negative. So that's there. And you can probably see already that I don't have the right answer. I've got 2x take away 3x, which is negative x. So that's wrong. So I just need them the other way around. So let's erase that. And we'll put the 3 in the other way around. So I'm going to put the 1 here and the 3 here. And I want the bigger one to be negative, so that's there. And positive there. Now let's check it. We've got negative 6x. Plus x, which is negative 5x, and that's correct. Now this method won't be for everybody. But let's try one more just in case it grows on you. So we want factors of 3x squared. That has to be 3x and x. I also know that both of the signs are going to be positive because of this. All right, we've got 5 and 1. We can either put it in like this, 5 and 1, or like this. And I'm just going to check them. Let's see, I've got 3 and 5 is 8. Actually, that was right the first way around. So there's our answer. Let's just have a quick check of that. I've got 3x plus 5x is equal to 8x. Done. Now, arguably the most common method taught these days is the product sum factor method. And it's a good method, but it does have a first step, which is to multiply the first and last coefficients. And if you forget that step, you're stuck. So we go 4 times negative 3 is negative 12. And now we continue as before. We want factors of negative 12 that add to negative 4. And they are going to be 6 and 2, and we want the bigger one to be negative, so negative 6, positive 2. Now we're going to take this minus 4x and change it into minus 6x plus 2x, like this. You see here? Now we're going to factorize the first two, factorize the last two, like this. So taking the 2x out of these two, and then this is one lot of 2x minus 3, and then joining them together, we get 2x minus 3 in brackets, 2x plus 1 in brackets. Let's try another example. Factorize 8x squared plus 18x, take away 5. So start by multiplying those coefficients. 8 times negative 5 is negative 40. And we want factors of negative 40 that add to positive 18. They're going to be 20 and 2. We want the bigger one to be positive, so positive 20 and negative 2. Rewrite this and change the 18x into these two terms. So instead of 8x squared plus 18x take away 5, we're going to have 8x squared plus 20x take away 2x take away 5. Now factorize the first two and the last two. So a common factor here is 4x outside of 2x plus 5, and take the negative out of here, negative 1, 2x plus 5. Bring this factor out the front, and there's our answer, 2x plus 5 in brackets, 4x minus 1 in brackets. Now there is a third method, the cross method, and this was the method traditionally taught. And it's particularly useful if these numbers are quite large. It's just a guess and check method. We start with a cross, and on this side we put the factors of 4x squared. So 4x and x, 2x and 2x. And on this side we put the factors of negative 3. So we've got positive 3 and negative 1, negative 3 and positive 1, and we've got to turn it upside down. Positive 1, negative 3, negative 1, positive 3. And now it's just a matter of cross multiplying to try and find a sum of negative 4x. And it's just brute force basically. We've got negative 4x plus 3x. Remember, I'm trying to find this. That's not it. Then I've got 4x, take away 3x. No. Negative 12x plus x. No. 12x, take away x. No. So it's not this one. Now let's try here. 2x times negative 1. So negative 2x plus 6x. We're getting close. I've got a 4 then at least. This is going to be it here. 2x take away 6x. So once we know that, I'm just going to cross these out, then this is one of the brackets and this is the other. So our answer is 2x take away 3 in brackets, 2x plus 1 in brackets. So which method should you use? Well, if you haven't decided on a method, I would really recommend the product sum factor method. It has the same method for monic and non-monic trinomials, so you just have to learn one thing. There's less trial and error, but don't forget the first step, and if coefficients are large, it can become quite difficult, like this question here. Now this is not a deal breaker. If you're really struggling with those non-monic quadratic trinomials, don't worry too much. It is only a small part of the course. Okay, the last thing we have to learn for this lesson is algebraic fractions. So let's start from the beginning. When we multiply fractions, we multiply across the top and across the bottom. So our answer is x squared on 15. If we have binomial numerators or denominators, we need to be mindful of invisible brackets. You see, we don't have to write those because of these long divided by signs. But when we multiply, we've got to put them back in. So our answer is x plus 5 in brackets multiplied by x minus 5 in brackets all over 6. Now let's talk about simplifying algebraic fractions, because I've seen some students do some amazing simplifying that's totally wrong. For example, what could they do here? Let me see. X cancels with this. 2 goes into 6 3 times. I'm not even sure what we'd get here. X squared plus 8. It's completely wrong. Here's the rule. We can only cancel products. So only if there are times signs. Any pluses or minuses that are not in brackets are going to stuff us right up. We've got pluses all over the place there. So we need to factorize this first. So factorising, we're going to get x plus 2 multiplied by x plus 3 all over x plus 2. Can you see what's going to cancel there? I mean, first of all, this is in brackets. They're invisible, but they're there. This can cancel with this. And our answer is x plus 3. Now this one I'm going to go through quite quickly. If you need to just pause and make sure that you understand, that's fine. But the factorization of this one here is x plus 1, x minus 1. This is x minus 1 all squared. This is x minus 2, x plus 1. And this is x plus 1. All right, now here's the thing. Because we've got multiplication signs here and here and here, we can cancel anything on the top with its identical term on the bottom, even across fractions. Okay, so let's see what cancels. We've got an x minus 1 here. I can cancel with one of those. We've got an x plus 1 that can cancel with that. And this x minus 1 can take out the rest of that. What are we left with? X plus 2. And one more. This is a really good skill to have. Can you see that we have the same terms, top and bottom, but they're opposite in sign? So we can actually factorize the negative out. Now if that's too quick for you, I'll show you the intermediary step. Let's go down here. So this is just the numerator. Factorizing the negative out gives me this, which I can then turn around. Now have a look what happens. We can cancel this with this, and we end up with -1. Now with division, we use the mnemonic keep, change, flip. We keep the first fraction, we change the sign, we flip the second fraction. So it becomes x over 3 times by 5 over x. What can we cancel? Those x's are going to cancel. So our answer is 5/3. With this one here, we're going to go keep, change, flip. Can you see that? What can cancel? This x plus 5 will cancel with that, and this 3 will cancel with this 3. Now be careful here. This is a 1 on top. 3 into 3 goes 1. So our answer is 1/2. And adding and subtracting. Now remember, we need a common denominator. And what we need to do is find the lowest common multiple of these two numbers, which is 6. The way to turn this first fraction into sixths is to multiply top and bottom by 3. And the second fraction, multiply top and bottom by 2, which is going to give us 3x over 6 plus 2x over 6, which is 5x over 6. And then, of course, we can get binomial numerators or denominators. So let's start by bracketing these. This time, the lowest common multiple is 4. So I'm going to multiply top and bottom here by 2 and leave the second fraction alone. That's going to give us this 2 in brackets x plus 1 all over 4, take away x plus 2 all over 4. And joining that together and expanding at the same time, I've got 2x plus 2, take away x, take away 2. Have a look at that minus going through the brackets there, all over 4. Tidying up, we end up with x over 4. And one more. Now in this case we need to factorise that denominator, and that's going to give us this. So instead of x squared plus 3x plus 2, I've got x plus 1, x plus 2. Now it's actually the same method as before, so I just need to make a common denominator. Now this term here has got an x plus 1 and an x plus 2, but this one here only has an x plus 1. So I need to multiply top and bottom by x plus 2. I'm also going to put in the invisible brackets. So I'm multiplying top and bottom by x plus 2. And then join it together, I get this. We need to expand that numerator, which gives me 4 plus x squared plus 2x plus 5x, which is 7x plus 10. I'm going to leave the denominator factorised. And then tidying it up, I get x squared plus 7x plus 14, all over x plus 1 in brackets, x plus 2 in brackets. And we'll finish off with one of my favourite fractions, which is double-decker fractions. You can see here we've got a fraction on the numerator and a fraction on the denominator. If you get a question like this, I would pull it out into this form. So bracket the top, divided by, because that's what this is, bracket the bottom. Now make a common denominator here, make a common denominator here, and then do keep, change, flip. All right, here we want x multiplied by x plus 3 on the denominator. I'm going to multiply this one top and bottom by x plus 3, and this one top and bottom by x. I'm going to do the same thing here, top and bottom by x plus 3, top and bottom by x, like that. Okay, so just have a look at that for a second. Now I'm going to do keep, change, flip, but I'm also going to tidy these up at the same time. So this is 2x plus 6 plus x, which is 3x plus 6, and this is 3x plus 9, take away x, which is 2x plus 9. Okay, now because we've got a times sign here, we can cancel. And what can we cancel? Let's see. This x plus 3 will cancel, and the x will cancel, and we're going to be left with 3x plus 6, or 3 outside of brackets, x plus 2, all over 2x plus 9. So my top tips. You can only cancel products, but with products, any term on top will cancel with any identical term on the bottom, even across fractions. Beware of invisible brackets and be systematic. Okay, that was a huge lesson. You may need to revisit this a couple of times. In our next lesson, we're going to look at surds and indices.